Hi, my name is Zhou, and today I'll be talking about the psychological representations that support human action perception. Humans are experts at action perception. What psychological representations support this feat? In particular, when evaluating similarities between actions, do humans tend to use representations specialized for body and pose, or objects more generally? To tackle this question, we first used two deep neural networks to extract pose and general object features from a large video set of everyday actions. Then we measured the perceived movement, visual, goal, and intuitive similarities across these action videos. Finally, we correlated these perceived similarities with both the extracted pose and object features to try to understand whether pose or object features best capture perceived action similarities. First, to extract pose and general object features, we used two deep neural networks, OpenPose, a pose detection network, and VGG19, a general image recognition network. While the majority of OpenPose layers are trained specifically for pose recognition, primarily detecting body keypoint locations and limb orientations, OpenPose's first 10 layers are actually made up of VGG19's first 10 object-trained layers, which have then been fine-tuned for pose. In other words, these 10 backbone layers in OpenPose are object recognition layers that are pose-tuned, rather than true pose-specific layers. To obtain our features in this step, for both networks, we fed in individual frames from 60 short naturalistic action videos, and then extracted features from the network's intermediate convolutional layers. Next, to measure the perceived action similarities, we showed participants the same 60 action videos that we fed into the neural nets, and asked participants to arrange these videos on screen according to their movement, visual, goal, and intuitive similarities. Videos that are perceived as similar are placed closer together, and videos that are perceived as different are placed farther apart. So now, which features, pose or object, best capture human similarity judgments? To get at this, we correlated each extracted neural net layer with each category of perceived action similarity. Here we plot these correlations, with OpenPose represented in the solid lines and VGG19 represented in the dotted lines. Immediately, we can see that the features from both the object and pose networks correlate best with movement similarity judgments, shown in the blue lines. In other words, our neural net features generally seem to better capture perceived movement similarities across actions. Now, to compare the two networks, we look at the differences between the dotted and solid lines for the first 10 layers. In comparing the original VGG19 layers and their pose-tuned versions in layers 1 through 10 of OpenPose, we see that for all four similarity judgments, there is little difference in the two networks' correlations with perceived action similarities. However, looking at the OpenPose network's transition from pose-tuned to pose-specific layers at layer 11, we see that the movement judgment correlations sharply increase, surpassing the movement judgment correlations for all pose-tuned layers. This jump as OpenPose switches from pose-tuned object recognition layers to pose recognition layers suggests that pose features are better at capturing movement similarity judgments across actions. In contrast, this same transition at layer 11 does not seem to affect the correlations with the perceived goal and intuitive similarities. In summary, through comparing perceived action similarities to pose and object features extracted from two neural networks, our findings suggest that neural net features are better at capturing movement similarities between actions, as opposed to visual, goal, and intuitive similarities. We also found that although tuning object recognition layers to extract pose features does not improve correlation with action similarity judgments, a pose-specific neural network architecture extracts features which correlate more with movement similarity judgments between actions. This suggests that humans may use pose-specific representations in understanding movement similarities between actions. There is still a lot of work to be done to understand human kinematic processing as well as the features in OpenPose. But as seen in this research, OpenPose and other neural networks are promising avenues for future investigations in this field. With that, I'd like to thank my co-authors, and I'd also like to thank you for your time and attention. Please let me know if you have any questions.